Hi guys, we are back again today. Physical changes. This is section 3, again 10.3. Okay. Again, some of you who did some of the optional assignments worked through a lot of this, and there are videos and things if you want to go back and watch them. Okay. So in the last video we learned what physical properties were. They're anything you can measure or see, observe without changing the substance, okay? So in this section, we're talking about ways to change things physically, okay? So I start and I end with the same substance, but it's going to look different, okay? So a physical change the matter's identity stays the same, which is what I just said. So you start and end with the same thing. I think that's a much better way of saying that, but hey. All right, so a physical change involves a change in size, shape, form, or state. Again, that's solid, liquid, gas, okay? Although the matter's identity stays the same, its properties might change a little bit. Like if I have water and I change it to ice, it's now solid. Its temperature is much different. It has a shape, okay? It has all different things than it does as a liquid, but it's the same thing as water. Okay, when food is chewed, matter undergoes a physical change in shape and size. Okay, matter undergoes a physical change when it changes from one, state to another. Okay, so when it goes from a liquid to a gas, like my example above. A change in state involves a change in the energy of the particle, how fast the atoms move. Okay, so in a solid, the atoms just kind of wiggle a little bit. They just kind of vibrate in place. In a liquid, they move much faster and they flow when you pour them. And in a gas, they're constantly moving all over the place at a really fast rate. Okay, the energy of the particles change when thermal energy is added. We could also think of that as heat. Is added or removed. Okay, when thermal energy is added to the particles, they move faster and the temperature increases. This isn't so bad, right? You can handle it. When the particles move faster, they can overcome the attraction or attractive forces that hold them together. Okay, and then let's move down here. When enough energy is added for a solid to change to a liquid, the solid has reached its melting point. When enough energy has been added to a liquid to change it to a gas, we call that the boiling point. Those two temperatures are unique to every single substance in this universe. So if I can take something that an unknown, and I want to figure out what it is, I just need to, one of the things I can do is take its melting point and take its boiling point, and then I can look it up to figure out exactly what it is, okay? Sometimes when energy is added to a solid, it undergoes sublimation, where it changes directly from a solid to a gas without becoming a liquid. There are very, very few things that sublimate, okay? There's two that I can think of easily that you'll know about. Dry ice, okay, is solid carbon dioxide, and it goes from a solid to a gas, no in between, okay? The other one is those solid air fresheners. And I didn't think about this one until I taught my 9th grade this year, and I used a different textbook. You know those little cone-shaped things that you kind of turn and open up, and you look at them and they're colored and they're gel, and then all of a sudden they're gone, that would be sublimation as well. Okay? All right, so when thermal energy is removed from particles, they move slower and the temperature decreases. So this would be called cooling, by the way, and for real language. Okay, I'll use a pen over so you can actually see. When particles move slower, they are drawn closer together by those attractive forces between them. Okay? All right, back page. Not used to talking so much. It's kind of weird, huh? All right, when enough energy is removed from a gas to change it to a liquid, we call that condensing. Just like in the water cycle. Condense, how about if we use the right grammar word? Condenses. Okay, just like the water cycle. When enough energy is removed from a liquid to change it to a solid, the liquid freezes. Okay, you know these words. They're normal words you use in your everyday language. We're just using some science words to attach them. If a gas changes directly to a solid without first becoming a liquid, it's called deposition. And I got one example of this: frost on a window. Okay, so you know, like the air, water vapor is outside, and it's in the form of a gas, and then especially like in the morning, you look and then there's frozen frost on your windows. Okay, it went from a gas to a solid on your window. Okay, all right, melting and freezing are reverse processes, as are, where am I? Boiling, what? Sorry, condensation and boiling. Where am I? Okay, so if I'm heating something up, I'm boiling it. If I'm cooling it down, I'm condensing it. Same thing, reverse processes. As are condensation and boiling. And then the other ones are sublimation and deposition. Okay, so if I go from a solid to a gas, I sublimate, and if I go from a gas to a solid, I deposit. Okay. Number 7, when something evenly mixes with another substance, we call that dissolving. And you guys see that like when you make Kool-Aid. Okay. Not everything dissolves in everything else. You guys know about salad dressing. That does not dissolve. Okay. Some types of physical changes are blank, such as when a solid changes to a liquid, then a liquid changes back into a solid. This would be reversible. And there should be an I, not an A. You know me and my spelling. All right, and then this is like a really important part for pretty much all of the universe, and especially chemistry. Okay, so mass is one of the things that is conserved. We cannot lose it. It cannot be created. It cannot be destroyed. It always has to be somewhere. So particles that are present before a physical change are also present after the change. Okay. Therefore, the mass is the same before and the same after. Okay, so if I start with ice cubes in a glass, okay, as they melt, I still have the same mass of water afterwards. Okay, the shape of it and the qualities of it might be different, but I still have the same thing. Okay, hope that helped you guys. Miss you. Hope to see you soon.